Alright, so our next question comes from 4.23 own. Wants us to determine the Fourier transform of all the signals given. So it gives us x naught of t. And then it gives you multiple versions of it where it's flipped. It is flipped and then flipped upside down and then time shifted and then multiplied by a coefficient. So before you even try analyzing all of that, the first thing you need to do is determine the Fourier transform of the regular x naught of t. So that's what we're going to do. Determine the Fourier transform. X of j omega is equal to the integral, the domain x of t times e negative j omega t dt. So we know the domain is 0 to 1, and we know x of t is e negative t. So 0 to 1, e negative t times e negative j omega t dt. Alright? So that's going to be e to the negative t 1 minus or plus j omega is these two simplified, 0 to 1 dt e negative t 1 plus j omega from 0 to 1 all over negative 1 plus j omega. Okay, so that's going to give us 1. So we got e to the negative 1 plus j omega over 1 plus j omega minus a negative, that's positive, 1 over 1 plus j omega. So x naught of, so technically it should be big X naught of j omega is equal to 1 plus or minus e negative 1 plus j omega all over 1 plus j omega. Alright, so that's our original x naught of t, or x naught of j omega. Okay, so this first one, A, what you can see is this whole signal is going to be x naught of t plus x naught of negative t. Okay? So when you look at your sheet, it actually shows you time reversal. Time reversal tells us that x of negative t is equal to x of negative j omega. And this is helpful because your x of t right now is equal to x naught of t plus x naught of negative t. So your Fourier transform is x of j omega equal to x naught of j omega plus x naught of negative j omega. That's what this will tell you. Okay? So just add the two signals. Okay, for A. So A, we have 1 minus e to the negative 1 plus j omega divided by 1 plus j omega plus 1. So you have to replace all j omega with negative j omega. That was an ugly j, sorry. So we got 1 minus e to the negative 1 minus j omega. Just like that, okay? 1 minus j omega. Just like that. Okay? So now we just have to add these and simplify, and then you will get your x of t. Okay, so let's do it. So to simplify, we're going to have to multiply this by 1 minus j omega. Multiply this by 1 plus j omega. Okay? let's just go over here and find the common denominator. So 1 plus j omega times 1 minus j omega. So that's going to be equal to 1 plus j omega minus j omega minus j squared omega squared. It's going to equal 1 plus, so j squared is negative 1. Negative 1 times negative 1 is 1 times omega squared. It's just omega squared. Okay? That's your CD, common denominator. Okay? So now, since we have a common denominator, we need to distribute this out to the individual ones. So minus e to the negative 1 plus j omega times 1 minus j omega. We're going to plug the denominator in later, just so it's not so cluttered, okay? Plus 1 minus e to the negative 1 minus j omega. All of this times 1 plus j omega. Okay? Like I said, we're going to plug the denominator in later, so don't think I'm just forgetting it, okay? So 1 times 1, that's 1. 1 times negative j omega, that's negative j omega. E to that times 1 is just that, so it's going to be negative e to the negative 1 plus j omega minus negative j omega times e to the negative 1 plus j omega. We're just going to change those to plus signs, okay? This is the first one, which is done. Okay, plus 1 times 1, which is 1, plus 1 times j omega is j omega, minus, so 1 times e, so e negative 1 minus j omega. Then negative e times the positive j omega is going to get negative j omega e to the negative 1 minus j omega. Okay, and then all divided by our common denominator of 1 plus omega squared. Alright, and so I know that you can see it because I can already see it. Some of these are going to group to make cosines and sines. So that's going to make us negative j omega e to negative 1 because we're taking this one out. Okay, that's a constant. Okay, e to negative 1 times e to the j omega. Right? Yeah, minus e negative j omega. Okay? And then these are going to match right here. Okay. So, going to have e to the j omega plus e to the negative j omega all times negative e to the negative 1. Okay? And then, of course, the ones match. And the j omegas cancel, okay? Okay? So, make this look just a little nicer. Alright. That's what it equals. And then now, we plug in our denominator. 1 plus omega squared. And now we can see that this is going to be a cosine, this is going to be a sine, 2 j. Okay. And let's just go ahead and plug it in then. Okay. So 2 minus 2e negative 1 cosine of omega minus, so we have 2j times negative j. So j times j is negative 1 times the negative, which is 1, times 2, which is going to be 2. Yeah, that's 2 omega e negative 1 sine of omega, all divided by our denominator, 1 plus omega squared. Okay. So the furthest that you can simplify this is just by taking the 2 out. So 2 times 1 minus e negative 1 cosine of omega plus omega e negative 1 sine of omega, all divided by 1 plus omega squared. So this is going to be your final answer. Alright. So hopefully that was helpful. I'm going to make B, C, and D into separate videos. Link them below. Alright, so back to 4.23. We're doing part B in this video. So in part A, we had already derived the x naught of t's Fourier transform. Okay, so now part B, we have x of t. Just in case you don't know where my pen is, x of t is equal to x naught of t. So it is rotated and flipped. So it's going to be x naught of t minus x naught of negative t. Okay? And your sheet doesn't say anything about minus, but I mean it should be common sense. You're just minusing it after you do the time reversal. So as discussed earlier, time reversal is going to be x minus t is equal to x negative j omega. Okay, and then negative x of negative t is equal to negative x negative j omega. Okay, so you're just going to be subtracting the time reversal of the original. Okay, so let's go ahead and do that. So x of j omega is equal to 1 minus e to the negative 1 plus j omega. Oops. 1 plus j omega minus 1 minus e to the negative 1 minus j omega 1 minus j omega. As stated in the previous video, you just replace all the j omegas with negative j omega. Okay, and that's what we did there on the second part, and we are just minusing it now. Okay, already found this. Common denominator is equal to 1 plus omega squared. Okay, actually I'll just rework it out for you. Okay, so we need to multiply this by 1 minus j omega, 1 minus j omega, multiply this by 1 plus j omega. Okay. I'm not reworking the common denominator, but I'll rework the top part. Common denominator is equal to 1 plus omega squared. Okay. So then 1 minus e negative 1 plus j omega. We're going to plug the denominator in later. Don't freak out. I'm not freaking it. J omega. Okay. Minus 1 minus e negative 1 minus j omega. Obviously, if you watch the first video, just go ahead and fast forward through this. I'm just doing this so somebody else, just in case they don't want to watch the first one, they can watch this one and still get it. What am I doing? No denominator yet. Alright, so 1 minus j omega plus, minus e negative 1 plus j omega minus j omega e negative 1 plus j omega. So minus, so I'm going to go ahead and just distribute the minus so I don't have to worry about it. Okay, so it's going to be plus negative 1 minus j omega plus e negative 1 minus j omega plus j omega e negative 1 minus j omega. Okay, and then the common denominator would be 1 plus omega squared. Alright, so this time the ones are going to cancel. The j omegas is just going to turn into negative 2 j omega. Okay, cancels that, and then we can group these and these. That's going to turn into a sine function, but I'm not going to just throw it out on you. I'll group it first. Negative 1 minus j omega minus e negative 1 plus j omega. Okay, and then these two will also group to make something nice. Okay, and that's looking like it's going to be a cosine function plus j omega e to the negative 1 minus j omega plus e to the negative 1 plus j omega. Okay, and all over the denominator 1 plus omega squared. Okay, so negative 2 j omega. This is going to turn into a sine, and these constants are just going to move out. Okay, constant, okay. You should just see it. 2j sine of j, or not j, of omega. Okay, this is going to be a cosine, 2 cosine of omega. Okay, plus 2j e negative 1, the constant we moved out. Okay, times sine of omega j omega e negative 1 cosine of omega. Okay. And oh, I forgot the 2. Whoops. Yep. And that is going to be the final answer. Hopefully that was helpful. Oh, just kidding. Can't forget the denominator. 1 plus omega squared. Now is the final answer. Alright, so hopefully if that video was helpful, I'll be doing part C and D. Alright, so now we are doing part C of 4.23 ohm, determining the Fourier transform of the signal. So, in the other 2 videos, we had already determined the x0 Fourier transform. So now we need to determine the Fourier transform of this signal. This x of t is going to be equal to x0 of t plus x0 of t plus 1. Alright, so this is a time shift. Okay. And a time shift in x of t is correlated into the Fourier transform. So, time shifting, I'm so sorry, that's ugly. Time shifting, okay, when x of t minus t naught happens, when you need to go to the Fourier transform, it turns into e to the negative j omega naught t times the Fourier transform. Okay, so x of t plus 1, so t naught must equal negative 1. Okay, so then you plug in negative 1 to this, it's going to be e to the j omega times x of j omega. Okay, so now we just need to add the signals. So x of j omega is equal to 1 minus e to the negative 1 plus j omega over 1 plus j omega plus e to the j omega times the same thing, 1 minus e to the minus 1 plus j omega over 1 plus j omega. Okay, let's distribute this. So actually, what we can do here is simplify it a little bit more before we start distributing everything out, okay? So this is going to be 1 plus e to the j omega. Oh, that's so ugly. J omega times 1 minus e to the minus 1 plus j omega over 1 plus j omega. Okay, so this is going to make it much simpler to distribute. Okay, so we have 1 times 1, which is going to be 1 minus e to the minus 1 plus j omega. Okay, then we have e times 1, it's going to be plus e to the j omega plus the two e's times each other, so it's going to be e j omega e negative 1 plus j omega. Okay, this is all going to be divided by 1 plus j omega. Okay, so now we need to simplify. Which is going to equal 1 plus e to the j omega minus e to the negative 1 plus e to the negative j omega, all divided by 1 plus j omega. Alright, and yeah, that looks like the most simplest form. That's going to be the final answer. Alright, if you didn't follow that, we took this constant out, okay? And so that left e negative 1 times e to the j omega okay, so okay, so finally part D of 4.23 to ohm. So in the previous videos we already defined the x of x naught of t and x naught of j omega. So now we are just focusing on the D part. So if you look at your sheet, so right now x of t is equal to t x naught of t. Okay, so this is going to be differentiation in frequency. Okay, so differentiation. Pardon my spelling if it's bad because I'm an engineer. In frequency. Okay, so in the time domain, if you have t, x of t, it transfers to the frequency domain as j d d omega of x of j omega. Okay, so basically you're taking the derivative of x of j omega with respect to omega and multiplying it by j. Okay, so that should be pretty easy for this. So x of j omega is going to be equal to j d d omega of 1 minus e to the minus 1 plus j omega 1 plus j omega. Alright, so if you remember from Cal 1, when you're taking the derivative of a fraction that has the, what's the word for it? Variable in both numerator and denominator, it's the quotient property. So it's going to be f prime g minus g prime f all over g squared. Okay, so f prime, so first f, let's define f is equal to 1 minus e to the minus 1 plus j omega. G is going to be equal to 1 plus j omega. Okay, so the prime of f is going to be 0. So f prime is going to be 0, and then the derivative of this is going to be negative j. So negative j e to the negative 1 plus j omega. And g prime is going to equal just j. Okay, So then let's put all this together. So f prime, which is going to be positive j, so it would be j e to the negative 1 plus j omega, times g, which is 1 plus j omega, minus g prime, which is j, times f, which is going to be 1 minus e to the minus 1 plus j omega, and all divided by g squared, which is going to be 1 plus j squared. Okay? So, we can take a j out of all this. J e to the negative 1 plus j omega times 1 plus j omega minus 1 minus e to the negative j omega all over 1 should just be minus, or I mean 1 plus, I don't know why I did minus j omega squared. Okay, so then let's go ahead and simplify this even more. So actually we're not going to do it like that. I don't like it. I'm going to change it up on you guys. I'm sorry. Let's distribute this first. So we're going to have j e negative 1 plus j omega plus j squared omega e to the negative plus j omega minus j plus j e to the negative 1 plus j omega all over plus j omega squared. Okay? So right here, j squared should turn into a negative 1. So it's going to be negative 1. Okay. And then now let's factor the j out, make it look better. What we can do here, yeah, let's factor the j out. So it's going to be j over 1 plus j omega squared times e to the negative 1 plus j omega minus omega e to the negative 1 plus j omega minus 1 plus e negative 1 plus j omega. Okay? And then now still have a j to multiply the whole thing by. Okay, so multiply all of this by j. J times j is going to be -1. Okay. So we're going to have negative, well, let's just leave -1 over 1 plus j omega squared. I don't want to leave any steps out for you guys. Just so we're going to combine these two. E2 negative 1 plus j omega minus omega e negative plus j omega minus 1. Okay. So then, multiplying the -1 to everything, we're going to have -2e negative 1 plus j omega minus plus omega e negative 1 plus j omega minus plus 1 all over 1 plus j omega squared. Alright, and that's going to be the final answer, guys. Sorry about the roundabout solution, but the main thing you need to focus on is realizing that this is differentiation in the frequency domain. Okay, right here. So anytime you see x of t having a leading coefficient of something that you're would be differentiating by, that's going to be the key. Same thing for all these other ones. You should know how changing the time, or x of t, will affect x of j omega. And most of it's on your sheet, so just realize that it's on your sheet. Okay?